So we've talked about things of type integer, things of type bool. Now it's time to talk about how we might put some of these things together in a collection. In an OCaml we do this using something called lists. What exactly is a list? Well, we'll say that a list is an ordered collection of items of like type. And what that means is that all the things in your list have to be the same. There can be 5 integers in a list or 3 booleans in a list, but we can't hold 2 booleans and an integer in a list, for example. So here's an example of a list containing some integers. So we write it out using semicolons between the items and the square brackets around the outside. What's the type of this expression? Well, it's a list, it contains integers, and so we write int list as the type. There are 2 important parts to a list. The first element we call the head, and we refer collectively to the rest of the elements as the tail. So the head of this list is the integer 1, and the tail of this list is the list containing 2 and 3. You can see that the tail of the list has the same type as the whole list. The whole list had type int list, the tail has type int list and 2, and the head has type int. We can have, of course, a list just containing one item. So this is the bool list, just containing one item false. Well, in this case, the head of that list is the boolean false, and the tail of the list is what? Well, it's the list containing no items at all, which is the empty list. And we can see that that has the same type again as the whole thing. The whole thing has bool list. The empty list in this instance has type bool list 2. And what about the empty list itself? Well, in this case, as the tail, it had type bool list, but in general, it has type alpha list because we don't know what kind of items are in the list yet. And what are the head and tail of this list? Well, it doesn't have a head and it doesn't have a tail. And so when we're writing later on functions which operate over lists, we have to be careful because there won't always be a head or a tail. So it's a little more complicated than writing simple functions to which there's always an answer for any input. How can we construct these lists rather than just write them down? Well, OCaml has a couple of built-in operators for this. The first is the double colon, which for historical reasons is called cons, and this is used to attach a single element onto the front of an existing list. So if I write 1 cons, the list containing 2 and 3, that will evaluate to the list containing 1, 2 and 3 in that order. And in fact, the list 1, 2, 3 can also be written 1 cons 2 cons 3 cons the empty list, and the cons operator has associativity such that these implicit parentheses are there, but we don't write them out. So you can see that this list is built up by consing 3 onto the empty list, consing 2 onto the list containing just 3, and then consing 1 onto the list containing 2 and 3, and thus the whole list is created. The second operator that's built in is the @ symbol, and that operator is called append. and it's used for appending two lists together in order. So if we write that, that will evaluate to the list containing 1, 2, 3, 4, and 5. So how might we write a function? Well, I suppose the simplest function on a list is one that finds its length. What type would that have? Well, it takes in a list, and it's going to give us an integer for the length. But what kind of list does it take in? Well, we're going to be taking the list apart and counting how many elements there are in it, but we're not going to be inspecting the individual elements themselves. So they don't need to be of a particular type. So in fact, this function is going to work on any list. You give this function any list, it will count how many items there are and return that as an integer. But it doesn't matter what kind of list you gave it. Well, we can start to write this out. Well, let rec length L equals. Well, we need to pattern match on L. And in fact, we can use some of the symbols that we've seen above as patterns as well to deconstruct lists as well as to construct them. So if we match L with the empty list, so that will match just the empty list, well, what's the length of the list, which is the empty list? It's 0. Simple enough. Base case. Otherwise, we must have a head and a tail, so something of that form. Here we're using cons as a pattern. Well, in that case, what's the length of that list? Well, it's 1 for the element h plus the length of t. And in fact, of course, because we haven't used h on the right-hand side, we can do the usual thing and replace that with an underscore, because there's no point in giving a name to something that we're not going to use. Okay, well, how does this function operate? Well, let's take an example. If we want to find the length of this list, well, it clearly doesn't match the base case, so we take it apart, and 1 is the role of h, or the underscore, and t is the list containing 2 and 3. So we get 1 plus the length of t, which is 2 and 3. And so we get 1 plus 1 plus the length of the list just containing 3, which is 1 plus 1 plus 1 plus the length of the empty list. Well, that's the base case now. So we get 1 plus 1 plus 1 plus 0, which is 3, which is indeed the length of our list.